Hello friends, this is Suyog Patil, Assistant Professor in Department of Mechanical Engineering, SIT COE at Rao. As we discussed in the previous lectures, the design of the clutch. In continuing with that, now today we are going to discuss the design of the brakes. The learning objectives. After reading this session, the student should learn about the different types of the brakes and their operating principles, their construction, working. Also, the student should learn about the braking torque capacity of the brake and the energy absorbed by the brake. Now, the introduction. The brakes are the mechanical devices which used for retarding the motion of the vehicle. Or also we can say the brakes are also used to stop the vehicle quickly without a short distance. Now we can see here, so this is the brake drum out of this brake, then this is the brake shoe, okay, on which this brake lining material is mounted, okay, and this when we apply certain force on this brake and we actuate this brake, then this brake lining will move towards outward direction. This brake lining will move towards outward direction and it comes in contact with this brake drum, and finally this rotating motion or this energy is released or energy is absorbed here. The brakes are also used to hold the vehicle at rest on an inclined road against the pull of the gravity. Or this also, the brakes are mechanical devices used to absorb the kinetic energy of the rotating body, or again it is converted into heat energy. Now, the principle of the brake. A moving vehicle possesses kinetic energy that is converted into the heat energy on the application of the brake. When we apply certain force or the efforts on the brake, this brake is in contact with this brake linings are in contact with the shoe, and this due to the frictional resistance or frictional force, the kinetic energy of the rotating body is converted into the heat energy. The heat is transferred to the surrounding air. This converted heat energy is transferred to the surrounding air. In the simplest form, a brake comprises a stationary brake shoe with a friction lining on it and a brake drum. The road wheel is fixed to the rotating brake drum, and the driver applies the force on the brake pedal that gets amplified. The applied force gets amplified here and pushes the stationary shoe to make in contact with the drum and stop its rotation due to the frictional force between these brake linings and the drums. And the heat is generated due to this braking action, and this generated heat is proportional to the force that brings the shoe in contact with the drum. This frictional force between this brake drum and this brake shoe, this heat generated depends upon these forces. Now, purpose of the brake. The main purposes of the brake are, in emergencies, to bring the vehicle to rest in the shortest possible distance, the brakes are required. Okay. Then again, to control the vehicle when it is in the hill station. Then to keep the vehicle in desired position after bringing it in complete rest when there is no driver. Now we will discuss the requirement of the brake. Application of the brakes should bring the vehicle to a relatively quick to stop. Okay, that means when we apply this brake, this vehicle should stop relatively quick. Then braking system components must require minimum maintenance. The maintenance of the braking system component should be lower. This is the requirement of the brake system. The pedal effort required to produce the minimum deceleration should be minimum and should not vary with the road conditions. This effort required to apply this brake should be minimum, and it should not depend upon the road conditions. It should have a minimum stopping distance and should require minimum time to actuate this brake. Then again, it should not involve any noise. Provisions for quick heat dissipation must be incorporated in the brake system. So these are the few requirements from the brake system. This capacity of the brake again depends on these 5 points. Okay, first one, it is unit pressure between the braking surfaces. The capacity of the brake depends upon the pressure, unit pressure between these braking surfaces. The contacting area of the braking surfaces, the radius of the brake drum, the capacity of the brake, again it depends on the radius of the brake drum also. The coefficient of friction between this brake drum and the brake lining material. Then the ability of the brake to dissipate the heat, the heat dissipation ability, as, or again we can say the energy being absorbed by the brake. Okay, the capacity of the brake depends upon this energy being absorbed of the brake also. Then design considerations. So here we will discuss few design considerations that we have to consider while designing the brakes. So effective heat dissipation should be there. Okay, so we have to consider this heat dissipation capacity of the brake. Then multiplication of the force, that means the efforts that we are going to apply. Okay, so it should be multiplied. Then sealing of the system, materials, that means coefficient of friction, heat resistance, wear rate, wear out resistance, wear out rate. Okay, so these properties also again we have to consider while designing the brake. Then front and rear forces, that weight transfer capacity, the variation in the operating conditions also, environmental conditions and other operating conditions. The legal requirements also that we have to consider while designing the brake. Then next it is type of the brakes. So basically there are three main types of the brakes. One, it is mechanical brake, hydraulic or pneumatic brakes, and electric brakes. Okay, so mechanical brakes are operated by means of the mechanical levers or mechanical elements. Then again these mechanical brakes are classified into different categories, that is block brake, internal or external shoe brake, disc brake. When this shoe in contact with this drum inner surface and this braking action is taking place, so it is called as internal shoe brake. And when this shoe comes in contact with this brake drum's outer surface, okay, and this braking action is taking place, it is called as external shoe brake, external expanding shoe brake. Okay, then again there are few types, that is single shoe brake and double shoe brake. Then hydraulic and pneumatic brakes. Hydraulic and pneumatic brakes, oil, or in case in pneumatic brakes air is used to actuate these brakes, and in electric brakes the magnetic forces are used, eddy currents are used to operate this type of the brakes. The first step in the design of the brake is to determine the braking torque capacity. The braking torque capacity depends upon the amount of energy absorbed by the brake. Now we will see here, this is the one object, okay, which is moving with velocity v1, linear velocity v1, okay, from this point number 1 to this point number 2. Okay, with this object is moving with velocity v2 at the second position. Similarly, this object is rotating with an angular velocity omega 1 and omega 2. When this object is moving from this point number 1 to point number 2, okay, and when we are applying the brake here, the speed of this object will reduce. Okay, so therefore while reducing this speed, this kinetic energy is released. So this kinetic energy released by this vehicle is absorbed by the brake. In automobiles, kinetic energy is released, but in case of this hoist or elevators, the potential energy is released. So we can see here the kinetic energy released here is 1/2 m v1 square minus v2 square, and the potential energy in case of this hoist and elevators is due to this change in the height. Okay, so we will see in details. So therefore the kinetic energy absorbed by the brake is, as we know, the kinetic energy is equals to 1/2 mv square. Okay, but here the velocities are varying, that means from v1 to the v2. So therefore the kinetic energy is equals to 1/2 m v1 square minus v2 square, where k is the kinetic energy absorbed by the brake in joules, m is the mass of the system in kg, and v1 and v2 are the initial and final velocities of the system in meter per second. So this is all about the kinetic energy absorbed by the brake. Similarly, kinetic energy of the rotating body we can write down in terms of this angular velocities omega 1 and omega 2. So therefore this kinetic energy is equals to 1/2 I omega 1 square minus omega 2 square. Okay, or again also we can write this kinetic energy is equals to 1/2 mk square into in bracket omega 1 square minus omega 2 square. Okay, where omega 1 and omega 2 are the initial and final angular velocities of the body in radians per second. M is the mass in kg and I is the mass moment of inertia of the rotating body, kg meter square, and k is the radius of gyration of the body. In certain applications like hoist and elevators, as we discussed, the potential energy is released. Okay, and when the body of the mass m falls through a distance h, okay, the potential energy absorbed by the brake system is Pe is equals to mg into h. As we know, the potential energy is equals to mgh. Okay, where m is the mass in kg, g is the gravitational constant, which is equals to 9.81 meter per second square, and h is the distance or height. Now the total energy absorbed by the brake depends upon this application. That means the potential energy plus kinetic energy in some applications. In some applications only kinetic energy is there. Okay, so therefore the total energy absorbed by this braking system is equals to kinetic energy plus potential energy. Total absorbed energy of the braking system is nothing but the work done by the brake. So therefore this total absorbed energy E is equals to mt into theta, where mt is the torque, braking torque in Newton meter, and theta is the angle through which the brake drum rotates during the braking period in radians. So that means this total energy absorbed by the brake is nothing but the work done by the brake. Thank you so much.